everyone. I am A. Nirisha, Assistant Professor in the Department of CSIT working in MLR Institutions of Technology. Today we are going to discuss about the next part of the dynamic memory allocations. So that is, we have in the last video we have discussed about the malloc alloc, and in this video we are going to discuss about the realloc and also the difference between malloc and calloc functions. So malloc and calloc are almost the same. See, both the functions are used for allocating the memory, but we have some differences that we'll check out. Next is the reallocation. So here reallocation means a reallocation of memory. Realloc means reallocation of memory. For suppose, consider some elements. For some elements, consider for 4 elements, the memory got allocated. So whenever we are solving a problem, for 4 elements, the memory got allocated by using a malloc or calloc. But that 4 elements are not sufficient for me. I require some other 2 or 3 elements to use. So at that time, the next to this, we need to allocate some memory, 2 or 3. So this memory allocation, the extra number of elements for memory allocation can be done by using this realloc functions. So here realloc is used for reallocation of memory. And coming to this syntax, see this realloc and the data type is void, old pointer, and next one is the new size, whatever the new size that you are assigning, and this is nothing but the pointer variable. And all the functions, all the DMA functions, malloc, calloc, realloc, all those functions will assign memory for the void pointers. We need to convert that void pointer into the integer pointer or float pointer or character pointer as per a wish. And the next, so that is the reason why here we have a void pointer. And the next one example, that is int a. By using calloc function, we are allocating the memory for n elements. So consider that n elements are 0, 1, 2, 3 and 4. Again, by using this realloc function, we are allocating for 2 more elements, we are allocating the memory. So here we must have that previous elements and also the whatever the new elements we require. For that also memory should get allocated. So these are nothing but the previous elements, and these 2 elements are the new elements that we are going to give to that memory. So this is nothing but this concept we are solving by using this realloc function. So here we have header file and stdlib.h header file. So as we discussed, malloc, calloc, realloc and free functions are defined in stdlib.h header files. And next is the main function, and we are declaring a pointer variable. And here we are declaring n and I and also n1. N is the old size and n1 is the new size. So n is the number of elements that you are allocating. Consider here initially we have given that n as 5 and n1 is the 2. So extra how many elements you want the memory to get allocated? So 2 elements. So n1, that 2 value we are assigning, the 2 value we are storing in the n1 variable. So that is the reason why one more extra variable we have taken here. And then next we are asking to enter number of elements, and by using scanf we are reading that n value, and by using this calloc function we are allocating the memory. So and the next by using this scanf inside the for loop we are reading all that particular elements. So consider, so here we are taking in this example. So in this example we are taking the number of elements as a 3. So consider my n is equals to 3. So for 3 number of elements, 3 individual blocks of memory will get allocated. So 4 bytes of memory. So consider that is 101, 102, 103, 104. The next 105, 106, 107 and 108. The next 109, 110, 111 and 112. And in this A will have the base address. The base address is 101. So that first byte of address will be assigned to that pointer variable. So by using this for loop and the scanf inside a for loop, we are reading all those elements. So here the values we have given it as 1, 2, 3. So the 1 will be read and stored in A plus I. A here is 101. So 101 101 plus I. I value is I is equals to 0. So 101 plus 0 will be equals to 101. So the first value will be stored in 101 address location. The next I value will get incremented. Next value we are storing in 101 plus 1. So if you are adding some integer or constant to this address, we need to multiply with the size of the data type. So it goes to the 105. 101 plus 4, that is 105. So the next value will be stored in 105 to 108 address locations. And next I value will get incremented. So next value we are storing in a plus I. I is 2 and A is 101. So to these two we are multiplying with the size of the data type. So 101 into 8, that will be is equals to 109. So this 3 value will be stored in next 4 bytes from 109 to 112 memory locations. So now next, these 3 elements are not sufficient for me to solve my problem. So I want the other 2 elements or 3 elements. So based on my problem, I need some extra 2 elements. And for that 2 elements also, the adjacent memory should get allocated. So for that, that can be done by using the realloc function. So we are asking to enter the extra size. So here the extra size we are giving it as a 2 number of elements. And the next, by using this scanf statement, we are reading that n1 value. So the 2 value will be stored in that particular n1 variable. And by using this realloc function, we are allocating the memory next adjacent to this. So next 2 bytes of memory will get allocated over here. So starting from 113, 114, 115, 116, and next 117, 118, 119, and 120. So total each 2 blocks that we are getting allocated by 4 bytes of memory is getting allocated. So here, see here, where we need to allocate that reallocate that memory in the A pointer. So next to this, and the next for how many number of elements? N into size of the int, n1 into size of, here the n1 is 2. So 2, for 2 elements, the size of the int is 4 bytes. So each 4 bytes of memory should get allocated for the 2 elements. So that can be done, and this realloc function we are converting it into an integer pointer. And the next, next that 2 values also we are reading by using a scanf statement. So here we have 2 elements, that is the reason why we can use 2 for loops, you can get it out. But if you have some not 2, if you have some more than 5 elements, so at that time obviously we need to go with the for loop. So that is the reason why I have taken here a for loop and the scanf statement inside the for loop. So here we are taking I is equals to n, and n value is nothing but the 3. So now I is equals to 3, and the next value whatever we have given the values as 4 and 5. So that 4 and 5 will be read in A plus I. So here A value is 101. So 101 plus I value, here it is 3. So plus 3. 3 into size of the data type, that is 4. So it will get 113. So the 113 value, the 113 value. So the next value, whatever we are reading, that is the 4 value we are reading, and we are storing in 113 address location. And the next I value will get incremented in this for loop. So I will be equals to 4. So next value we are storing in A plus I. A is 101 and I will be is equals to 4. So 4 into 4, that will be is equals to 117. So next value we are storing in 117 address location, then the next 4 bytes. And by using this printf inside the for loop, we are printing all the values from starting address to the all the 5 elements. So see here, check the condition here. We are taking I is equals to n and I less than n plus n1. So we are taking, in the for loop, we are giving the condition for n plus n1 because we need to read for the next 2 elements also. So that size, so that n plus n1, n is 3 and n1 is 2. So 3 plus 2 will be is equals to 5. So the condition is 3 less than 5 and here the 4 less than 5. The condition will be true. And next, if I is getting incremented 5. If 5 less than 5, the condition will be false and we are coming out of this for loop. Right? So here also the same condition we need to take because we are printing all the new size elements and also the old size elements. So new size, old size is n and new size is the n1. And here we are starting from I is equals to 0. So 0 to n plus n1 till n plus n1 we are printing all the values that are present in that particular array. So this, before we have a star, if we have a star, we'll get the value that is present in that particular address. So all those values 1, 2, 3, 4, 5, all the values will get printed. So this 1, 2, 3 are the elements that we got the memory allocation by using the alloc function, and this 4 and 5 are the elements that we got memory allocation by using the realloc functions. The next is the difference between the malloc and calloc. A malloc stands for memory allocation and calloc stands for continuous memory allocations. And malloc take only one argument. So we have seen the syntax. See here, n into size of the data type. Here we have only one argument. So malloc function will accept only one argument. And calloc function takes two arguments. See, n is one argument and also the size of the int is the other argument. And next, malloc is used to allocate a single large block of memory with the specified size, as we just now said in the previous lecture. And it is used, and coming to the calloc, it is used to allocate the specified number of blocks of memory with specified size. So complete a large number of memory will get allocated, and here blocks of memory will get allocated depends on the size of that data type that what we are using. And the next default value for that particular memory allocations, here we have as garbage value in the malloc. But coming to the default values of the calloc will be zeros. So initially, if we don't read any values, before reading the values to that particular memory allocation will get 0. And here coming to the malloc, some garbage values will get allocated. And this is the syntax malloc, and this is the syntax for a calloc. Thank you.